Alright, for math, we've already talked about factors of numbers. Remember that factors are, like factors of 6 are 2 and 3, and 1 and 6. Those are your factors of 6. But what about a multiple of 6? Well, a multiple is a product of that number and a counting number. It's kind of a fancy way of saying counting by sixes. So 6, 12, 18, 24, 30, 36, and so on. All of these numbers here are multiples of 6. So what are the first 5 multiples of 4? So of 4, the first 5 would be 8, 12, 16, 20, 24. And a nice way to think of it is this one here is 2 4s, or 2 times 4. This one is 3 4s, or 3 times 4. We have 4 times 4, 5 times 4, 6 times 4, and so on. So those right here are all multiples of 4. Alright, then the first 10 multiples of 8. The first 10 of 8. So we don't really start with 8. We think it's got to be multiples of 8. So the first one would be 2 times 8, which is 16. Then 3 times 8, which is 24. Then 4 times 8, which is 32. Then 5 times 8, which is 40. Then 6 times 8, which is 48. Then 7 times 8, which is 56. Then 8 times 8, which is 64. Then 9 times 8, which is 72. Then 10 times 8, which is 80. Then 11 times 8, which is 88. And I think I might almost be at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. It asks for the first 10 multiples of 8. Alright, and then here it says, is 54 a multiple of 6? Explain how you know. Is 54 a multiple of 6? Well, we have 6, and to find its multiples, remember you just count it by 6s. So we have 12, and then 18, and then 24, because that's 2 times 6, 3 times 6, 4 times 6, 5 times 6 is 30, 6 times 6 is 36, 7 times 6 is 42, 8 times 6 is 48, 9 times 6 is 54. Hey, look at that. Is 54 a multiple of 6? Yes. And it says explain how you know. Well, 6 times 9 equals 54. So that's how I know it's a multiple. Because remember, our definition of a multiple is a product of that number, so the number 6, and a counting number. A counting number just means like a whole number, not like 9.5. So 6 times 9 gets you 54. This asks, is 6 a factor of 40? Now this is different than multiple. It's not like counting up by 40s. 6 being a factor of 40 means like your factors of 40 are like 4 times 10, or sorry, 4 and 10. Those are some factors, or 1 and 40. Right, because you can multiply those together to get 40. So is 6 going to be a factor of 40? In other words, can I do 6 times something to give me 40? Well, to figure that out, let's do division. 40 divided by 6. What times 6 gets me close to 40 without going over? 6, 36. Nope, look at that. I'm going to have a remainder. So this one is no. 6 is not a factor of 40. What are the first 5 multiples of 9? So we have 9. To get our first 5 multiples, remember you go 2 times 9, which is 18. 3 times 9, which is 27. 4 times 9, which is 36. 5 times 9, which is 45. And 6 times 9, which is 54. So those are our first 5 multiples. Now this asks, what are the factors of 63? Remember, factors are 1 and 63, let's see. Can I think of any other ones? Oh yeah, I know that 9 and 7 make 63. But now I can't really think of any other ones right now. Now, that doesn't mean just give up. Remember how yesterday we kind of had like a little chart that looked like this, and you did 1, 63, 2, 3, 4, and so on? Well, you really have to keep checking, like a lot, to see if there's more factors, because there might be more than you think. I'll give you a hint though. If 2 is a factor, then this number has to be an even number. Because look, for 63, if we're going to try dividing that by 2, we're always going to get a remainder. Odd numbers don't have a factor of 2, ever. So that one's not going to be a factor. But we could check 3. Let's try 63 divided by 3. 2 times 3 gives me 6. And 1 times 3 gives me 3. Hey, I have no remainder. So look, those are factors. 3 and 21 actually are factors, which you wouldn't really have known unless you tried dividing. Let's try dividing it by 4. 63 divided by 4. Nope, that is going to give me a remainder. I know that 63 divided by 5 isn't going to work for us because if you count by 5s, you're never going to get to 63. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. See, I'm already past it. So one other one we could try is 6. 6 divided by 63. But I already know that that's not going to work because 6 times 10 is 60. See, look, if I go like this. Oh, yeah, that's not going to work. I'm going to get a remainder. Okay. And so since we tried 6, we don't really need to try anything else because we've already gotten up to 7. So we're pretty much done. Those are our factors. It says, is 63 a multiple of each factor that you listed for exercise 25? Explain how you know. Is 63 a multiple of each factor? Meaning, is 63 a multiple of 3? Or is 63 a multiple of 21? Or is 63 a multiple of 9? Or is 63 a multiple of 7? Yes, it is a multiple, because if we were to count up by 7s, we'd have to go 9 times, right? Because 9 times 7 gives us 63. If we were to count up by 7s, we would eventually get to 63. So yes, it is a multiple. Or what about 9? If we were to count up by 9s, we would get to 63. If we were to count up by 21s, we would get to 63. So yes, it is. Oh my goodness, I didn't realize there was so much more. All right, tell whether 7 is a factor of each number, right? Yes or no. So for 7 to be a factor, we'd have to be able to do like 7 times something to get it. But 7 times 1, yes, that gets us there. Can 7 times anything give us 84? I don't think so, but why don't I try dividing to see? Actually, yes, look at that. So, is 7 a factor of 84? That's going to be a yes. This one's also a yes. Is 7 a factor of 93? I don't think so, but I'll check. Nope, because look, I'm going to have a remainder in the end. So no. And I know that 7 times 7 gives me 49, so that one is a yes. This says, tell whether each number is a multiple of 9, right, yes or no. So that means if we were counting by 9s, would we be able to get there? It's kind of the same, actually, as what's up here. So 9 times 3 gives me 27, so I know that, yes, it is a multiple of 9. Whereas nothing times 9 is going to give me 30. I could try dividing it out, but I can see right away, no. Does anything times 9 give me 81? Yes, 9 times 9 gives me 81. Does anything times 9 give me 99? Yes, 9 times 11. All right, we're going to skip this part, and the very last part for us is we're going to use this rule to complete the pattern. So this asks us to skip count by 6, meaning we have 6, and then 12, and then 18, 24, 30, 36. So you could just keep adding by 6 in your head, or use your fingers. 36, 37, 38, 39, 40, 41, 42, 48, 49, 50, 51, 52, 53, 54. Or you could think this is 1 times 6, 2 times 6, 3 times 6, 4 times 6, and so on. So counting by 5s, we know that. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Counting by 7s, 1 times 7 is 7, 2 times 7 is 14, 3 times 7 is 21, 4 times 7 is 28, 5 times 7 is 35, 6 times 7 is 42, 7 times 7 is 49, 7 times 8 is 56, 7 times 9 is 63, and 7 times 10 is 70. This one says to skip count by 12, so we have 12, 24. Now you might not know your 12s off the top of your head, so you might have to do some counting with your fingers, or you can do like this. Add 12 on each time. So our next one would be 36, and then add on 12 to that. Our next one would be 48, add on 12 to that. Our next one would be 60, and so on. We won't finish it because this video is getting long. All right, this asks you to list all the factor pairs for each number. So what you can multiply together to get that number. I'm going to grab my book real quick. Give me a second. I want to be able to tell you how many factor pairs each one has, because otherwise, yeah, we're going to get confused. So let me just warn you right now. Because sometimes it's hard to know if you've gotten all of them, right? So I'm going to check for you. Okay, so this one has 2 pairs. And I'll help you with this one right now. 2 pairs means it can be 1 and 49. And 7 and 7 are your 2 factor pairs. This one has 1 pair. This one has... Oh, sorry, this one has 3 pairs. And this one has 1 pair. Okay, for these you have to tell whether it's prime or composite. Remember again that if it's prime, that means that it's only 1 times itself. So like if 29 is prime, the only factor pair you can come up with is 1 times 29. So then you would write that it is prime. You can just put P and C if you want. For composite, it has to have multiple. So like for 49, that's a composite number because it has 1 and 49 and 7 and 7. Telling whether 6 is a factor of each number just means like, can I multiply 6 by something to get that number? And if it's a multiple, again, can I multiply something by 8 to get that number? Then you're just going to follow these rules for that part. I think that's pretty simple. On the back here, you do not need to draw a rectangle model. This one's going to be extra credit here. And then these, seriously, don't overthink it. You just need to like solve the problem. So you'll remember that you always do parentheses first. So you would do, like in this problem, you do 3 times 7, which is 21, and then you'd add 2 times 10, so we get 21, and you're supposed to add 20, and then it says that equals h. That just means in the end, h equals 41. All right, number 10, I am going to ask you to do, you can look back at your notes to figure out your answer to that one, because we did answer it, I think yesterday on... Yeah, this one is 2 the only even prime number. All right, you've got this. Let me know if you have any questions.